Okay. So good afternoon, everybody. So first off, I was a little behind on grading. This totally slipped my mind, but your homework number 6 is now graded. Then if you go into the classroom under homeworks, under homework solutions, you can see the solutions to homework number 6. Exam number 4 is still on Thursday. So we still have our exam number 4 next class. And your review lecture is posted in the classroom now. So I forgot to make this available last class, but if you go to the course content, you go to week 15, you'll see this new YouTube video that's posted there. The video is like an hour long, so it's not that long, but it's a review lecture for the exam. Okay, so it's what I would have been giving today if I had not had to cancel class last week. But the review PowerPoint is there that I give. My notes are there as well. So, you can download it and you can see the notes on the exam. And you can see, like, I literally walk through, like, what are the questions, on the exam. And then I do one example of all the problems for you. Okay. So I highly encourage you to spend the 1 hour, watching the video and reviewing the notes, because that'll be the best way to study for the exam. Homework number 7 is still due Thursday. It's due, second. It's due at 11:59 p.m. So it's actually due after class. So if you're running a little late, you can still get that in. And then the big change is the syllabus says I dropped the lowest exam from exams 1 to 3, but not exam number 4. But because we lost a day right at the end, here's the deal. Come and try exam number 4. Okay, you still have to come and take it. Okay. If it ends up being your lowest exam grade, I will just drop it and just count your exams 1 through 3. However, you still need to show up and at least try the exam. Okay. Got to give it at least your best effort. These topics are very important. But if it does end up being your lowest exam score, I'll drop it. Okay. So that's just a change to the syllabus.
That's fair.
A once daily pill.
Does that sound okay to everybody? Okay. Yes. So just please still come. Just give it your best shot. It's not, honestly, I don't think the exam is too hard. I think it's 12 questions. If you go home tomorrow, or you probably are all home right now, but if you just spend a little time tomorrow, just carve out an hour, watch that review video, I promise you'll be good for the exam. Okay. And then I also still drop your lowest homework too, out of all the homeworks 1 through 7. Okay. Yes, Jamie. Sorry, someone posted a question. Yes, on the review lecture, there is. I do one problem. So watch the review lecture. Yes, I cover everything that you need to do well on the exam. Okay, I promise you. Promise. Okay, so what I want to do today then is I want to burn through really quickly 2 final topics, because these make up a good portion of your last exam, and they're pretty straightforward. Just load up your TI calculator if you haven't already done so. All right, I'm gonna just show you how to get to this stuff done with your TI calculator today. It's like super straightforward. And you're going to use your TI calculator on every question on the exam. Okay, so just have that handy. All right, but before I get started on the last 2 topics, does anybody have any quick questions they want to ask me? No questions, anybody? Okay. All right. You guys ready then for the final lecture of the class?
Yes, we are.
All right. I hope so. Okay. So here's what we're moving into. Okay. This also covers, I believe, questions 2 and 3 on your homework. Okay. So after today's class, you'll be able to finish all of homework number 7 as well. Okay. So last class, and I'll move on in a second. This was a week ago. We were talking about hypothesis testing for a mean when sigma, the population standard deviation, was known. So now what we want to do is we want to move into hypothesis testing for a mean. Again, it's all covered on the review lecture, but it's 12 questions. Okay, so watch that 1 hour review lecture when you get a chance. Okay, just, if you're like me, you're going to have to skip a night of Netflix. I'm sorry, but it's all covered there. Yep. And if we have time at the end of class, I'll talk about the exam. Okay. All right, let me burn through this stuff. Okay, so hypothesis testing for a mean, this is when the population standard deviation is unknown. All right, so this is kind of a review from last class real quick. So hypothesis testing, what it does is it tests the validity of a claim. Okay. And so we had 2 outcomes, right? We could reject the null hypothesis. What that means is evidence supports the alternative. Or you could fail to reject the null. And what was going on here was evidence does not support the alternative. Okay, and if anybody could help me out really quickly here, what were the 3 types of tests we had in hypothesis testing? Does anyone remember what they were called? We had something called a left-tailed. What's another one?
Right-tailed.
Yep, we had a right-tailed. And then what else? Did we have something called a two-tailed? Does that ring a bell?
Yes, we do.
All right, give me 1 second. And I said that there were keywords that kind of gave away, what type of test these were, right? Left-tailed, it was decreased, gone down. Right-tailed, increased, gone up. Two-tailed were that it's changed or it's different. Okay, so here's what we want to do now, okay? We want to expand on these topics. And is everybody okay if I go to the next slide? Does anybody need me to stay? All right, so we want to expand on these topics and talk about hypothesis testing for a mean when sigma is unknown. And it's actually, I'm gonna be honest with you, it's actually like super straightforward, the process. It's like almost perfect. It's almost the same as what we were learning a week ago. So when sigma is unknown, the population standard deviation is unknown, you estimate it with S, okay, which is the sample standard deviation. Now, we actually talked about this when we were doing confidence intervals. You can no longer use the normal distribution here, okay? Does anybody remember what distribution we learned after the normal distribution?
Is
It was just a single letter from the alphabet. It was something distribution. Everyone's just like, I'll be quiet and see if someone else answers. You guys got to use it on your homework. Actually, it's homework 6. So no longer use normal distribution. Instead, what you're going to do is you're going to use what's called the t distribution. Okay. And that's actually not a big deal. Okay. So what you're going to have to use here is just basically what we're going to do for this lecture here is it's just a different option in your calculator. All right. And so it's going to be basically the same exact process as last week. We're going to still go through the same 5 steps. It's just you're going to use a different option in your TI calculator. So I'm going to flip to the next slide unless anybody has any objections. So if you remember last week what we were doing was we were using the z-test, okay? So for this week, what we're going to learn today now is we're going to learn option number 2, the t-test. So use this to test a hypothesis for a mean when sigma is unknown. Okay. So as we go through this today, have your handy TI calculator handy. Okay, just have it out because we're going to use it literally on every single problem. Okay. So to complete, yes, I did, Rebecca. So you'll have to just watch the recording. Okay, it's there. I got to move on. No problem. Okay. So does anybody remember how many steps there were to hypothesis testing? It was a blank step process.
5 steps?
That's it. Yeah. So here's the thing. Here's the 5-step process for hypothesis testing a mean when sigma, and this is, sorry for a little bit of a typo here, sigma is unknown. Okay. And it's using the p-value approach. So we're going to get a chance to practice this a bunch today. All right. So it's the same processes as last week. Step 1, the first thing you're going to do is you're going to define the parameter. So you're going to let mu equal, which is something like the mean that you're investigating. Let mu be equal to the mean, blah, 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 blah. And we'll get a chance to practice this. The next thing you're going to do is you're going to set up the test. Okay, so you're going to have to pick from either being a left-tailed. So that's going to be mu is equal to a number. And your alternative is, wait a second, no way, mu is less than a number. Then you have right-tailed. Which is mu is equal to a number. And the alternative is, wait a second, no way, mu is greater than a number. And then you have a 2-tailed test. Mu is equal to a number, and you're testing, no way, mu is not equal to that number. All right, then step 2, this will be given to you. You're going to select the level of significance, okay? That's going to be my alpha, okay? We use this to help us make a conclusion in the final step. Step 3, you're going to compute the test statistic. We're actually going to just, usually I do this one by hand, but we're actually going to just use the calculator for this. Okay, when we jump to our first calculator example, you'll see that this is given in the output. Okay, and it's just, in this case, it's a t-score, but the formula looks almost exactly like a z-score. So it's a z-score formula. Just replacing S, or just replacing S for sigma. So if you look back in your notes from last week, you'll see that. Then you find the p-value of the test. This is going to be just some number between 0 and 1. Okay, and you use this to compare it to alpha. Okay, so you compare to alpha, okay, from step 2. And so your final step is your conclusion. Okay, so if your p-value is less than the level of significance, so if p-value is less than alpha, you're going to reject the null. Okay, you're going to say the null is incorrect. If the p-value is greater than alpha, you fail to reject the null. And look, after today's class, because all we're going to literally do is just a bunch of examples. If you can correctly do step 1, okay, if you can correctly do step 1, then the rest of the stuff just falls into place. Then the rest of it is just calculator stuff. So step one is the hardest step. If you can correctly set up the test, boom, it's going to be a piece of cake. Okay. Is everybody ready to jump into just examples?
Yes.
Okay. All right, let's do it. So here's example 1. According to the Department of Transportation, okay, the DOT, the mean commute time to work in the United States is 26.1 minutes. So according to the Department of Transportation, what they're saying is, look, on average, it takes workers 26.1 minutes to get to work, okay? So an economist believes the mean commute time in the New York City area is higher than that, okay? You know, it's New York City, there's a lot of traffic, maybe you have to take the subway, who knows? Okay, so the key word, if you look in there, you see the word higher, okay? What does that imply the test will be? Like, that's a keyword that's going to give away what type of test this is.
It's gonna be a left side.
So is it going to be a less than or a greater than?
It's a greater than.
So it's going to be actually a...
The right one, yeah.
Yeah. Whenever, this is a keyword here that tells me that I'm going to have to set up a right-tailed test.
I think you said 3 of them, the less than, the greater than, or when it has changed.
Yes.
That determines, right?
Yes. Mm-hmm.
Thank you.
Mm-hmm. So the economist, to test her claim, she samples 30 commuters, okay? So right there, you're given the sample size. And finds the mean commute time. So you're given the sample mean. X bar is equal to 33.2 with a standard deviation of 15.8. So this is really important. In the problem, unless it literally explicitly says the population standard deviation is this, that standard deviation is S. That's the sample standard deviation. Okay, so what that tells me is I'm going to need to use this t-test in my calculator. Okay. Then the next thing it says is test the claim at the 0.05 level of significance. Okay, so what we're going to have to do now is we're literally going to have to walk through the 5 steps of the hypothesis test. Okay. All right. So step 1, you're going to have to set up the test. So now here's the thing. The first thing you're going to have to do is you're going to have to define the parameter. Okay. So what are we testing here? I need some help on this. Okay. Like, what are we doing here? You know? What mean are we investigating? That's the thing. So we know what the mean is of everybody in the United States, but what area of the country, all right, is the economist specifically interested in? Mean commute in New York City. Thank you, Melissa. Yes, we're going to let mu be equal to the mean commute in NYC, New York City. And look, the word higher here, okay, that told me it was going to be a right-tailed test. So it's mu is equal to a number, and we're investigating no way mu is greater than that number. Okay. Well, look. Do you notice how it says that the mean in the entire country in the United States is 26.1 minutes? Does everyone see that right in the first sentence? The mean commute time in the United States is 26.1 minutes. And look, all we want to test to see is, you know what? I think it's higher. I think the mean in New York City is higher than that. Okay. It's the New York City area. So what we're going to do is we're going to start with the assumption, our null is what we assume to be true, that New York City is just like everybody else on average, that the mean commute time is 26.1 minutes. And what we're looking to show evidence for is no way, it's higher. It's got to be greater than that number. All right, once you correctly set this up, the rest of it's, you'll watch, your calculator is going to go boom, 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 and we're going to get the answer really quickly. All right, level of significance. It's given right here. All right, now everybody, grab your trusty calculator, okay? All right, everybody grab your, it doesn't matter if you have the TI-83 or the TI-84, it literally does not matter, okay? So everybody grab your calculator and hit the stat button right here, okay, stat. And you're gonna scroll over to tests. What we learned last week was z-test, okay? So this week, what we're going to do is we're going to use t-test. So everybody scroll down to number 2, and you're going to hit enter. Okay. Up at the top, you should see 2 things. You should see data and stats. Okay. When you're given just the summary statistics right here, N, X bar, and S, you're gonna have stats. Okay. So just make sure. For example, if right now you see data and it looks like this on your calculator, okay, scroll over to stats, hit enter. And now what we have to do is we have to put the relevant information in here. Okay. So scroll down, mu sub 0. That comes from the null right here. Right, so it's 26.1. You hit enter. Now X bar, that's this over here, this 33.2. Boom. S sub X, that's your standard deviation. So you're going to put 15.8. And then N is your sample size. Well, look here, this economist, she samples 30 commuters. So you're going to do 30. Now what you have to do, the not equal, the less than, the greater than, you need to make sure that it matches your alternative. So you're going to scroll over to see the greater than sign. And you're going to hit enter. How many people have been following along with me right here? Just let me know in the chat. Like, do you have what I have on the screen right there? All right, Melissa does. Okay, good. A couple people do. Okay, at least 2. So then once you have this, scroll down to calculate right here on your calculator. Calculate. Right, how many people see this output on their screen? Anybody else? Okay, good. 3 people. Okay. Well, look here. You see this first thing, T? This is your test statistic. So it's T is equal, my test statistic is 2.461. So what we're really, really super important and interested in is this next thing here called the p-value. So P right here stands for the p-value. Excuse me. P is equal to 0.0100. I'm going to go out 4 decimal places. 0.0100. Okay. So let me ask you this. Was at least using the calculator? Like, is using the calculator not so bad here? Okay. Well, once you get this done, now all you have to do, your next step, is you have to make a conclusion. Okay. So you're going to look at your p-value. Is the p-value less than or greater than the level of significance? Yeah, since the p-value is less than level of significance, alpha. So then just look back to your notes. Well, what does this mean we do? Excuse me. If the p-value is less than the level of significance, we reject the null. We reject the null. So when you reject the null, you're saying this probably isn't true. And evidence suggests the alternative is true. So what's going on here? What this means is like, look, it does seem like the mean commute time in New York City is higher than the mean commute time in the United States. All right, would you guys all agree that, you know, just once you get step 1 put up, I mean, using the calculator is pretty straightforward? Like, really what the hard part is like, yeah, just once you, it's just figuring out how to correctly set it up. And then once you get it set up, it's like boom, 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 boom. The calculator really goes through the rest here. All right. You ready to see another one? Okay. All right, so for this next one, I highly encourage you to pay attention. Like if you're kind of like half paying attention, half not, you got something going on in the background, pay attention to this next one. It's probably what the one on your exam number 4 looks like. And I also think it's kind of what the one on your exam or on your, excuse me, on your homework is like. Okay, so pay attention to this next one, okay? Everybody okay if I go to the next slide? Okay. So here's the problem. According to the Department of Education, college students spend an average of 120 minutes watching online lectures each day during the corona quarantine, the COVID quarantine, Okay. So look, during the lockdown, when everyone was stuck at home for a little bit for a while, I guess, what the Department of Education is saying, look, you know what? Everything was switched into online learning. So college students across the country were spending 2 hours a day watching online lectures. Okay, whatever, that's fine. But an educational researcher at WCC, okay, here wants to conduct a test to see if the mean is different, so that the mean is different for students at WCC. Right, so when you see that word, we want to see if the mean is different. What type of test is that kind of hinting at that we're going to need? Yep.
That's going to be a change.
Yeah, two-tailed test. Okay, so now we want to test to see, so we got to collect data, okay, to test to see if the mean is different for WCC students. So to conduct the test, she samples 18 students. Okay, so you're given your sample size. And recorded how many minutes they spent watching online lectures each day. And look here. Instead of being given the summary statistics, you're given the raw data. So you're not given X bar and S. You're given the raw data. Okay. And that's okay. It's not a big deal. Okay, look. So if you look here, these are the 18 students, how many minutes they spent per day watching online lectures. So someone did spend 120 minutes, 115, someone only spent 40, and then somebody was spending 180. So it's all over the place. All right, so it says conduct the test at the 0.05 level of significance. So it turns out it doesn't matter if I give you the raw data or the X bar S, your calculator can still do the hypothesis test for you. So it can still be solved, you know, really, really easily. Okay. All right, well, I'm going to go to the next slide, and don't worry, we're going to come back to this slide in a second, and let's begin setting it up. Okay. So the first one here, got to set up the test. So we're going to let mu be equal to something. So we know what the mean time college students across the country spent watching online lectures each day, okay, during the quarantine. So what mean are we interested in? Okay, like what are we investigating? The mean of who specifically?
WCC students.
Yeah. So we're investigating the mean time WCC students spend watching online lectures daily. Okay. Right. And this was specifically during quarantine. And so the key word again was what? That told me what type of test this was?
Different.
Yeah, the key word there was different. So this tells me it's a two-tailed test. So it's mu is equal to something versus mu is not equal to something. Okay. So what am I going to set it equal to, and what am I looking to show evidence that it's not equal to? Yeah, Melissa has it right there. Well, look, let's just start with the assumption that WC students watch just as much on average. And what we're looking to show is no way, it's a different number. Okay, maybe not. I don't know. That's why we're conducting this hypothesis test. So next, step 2, level of significance. It's given right there. Next, it says compute the test statistic. So what we're going to do is everybody, I'm going to go back a slide real quick, okay? Grab your trusty calculator, okay? what we're going to have to do is we're going to have to take this data and plug it into our calculator. All right. So does anybody remember how to plug data into their calculator?
Go to stat,
Stat,
edit.
edit, and then it's number 1. So under edit number 1, you're just going to hit enter.
And if the data's there, you scroll all the way up to L1
Okay.
and you hit clear.
Clear. And then enter. Yep. So look, under your calculator, under L1, you're going to have to input all this data. Okay. So let's start, follow me. So I'm going to go 120 and enter 140, then enter 122. And you just have to go through this process. It takes a little while, but not a big deal. $100, chugging along, 126 and 40 and then 95. So under L1 here, what you had to do is you had to have all the data plugged in there. Okay. Now, I'll give you a second, everybody, to have plug the data in. Okay. So this is really cool. Okay. What I'm going to do next in my calculator after you have it all plugged in is I'm going to click the stat button. And you're going to have to scroll over to tests. And when you're given the raw data, go to number 2. Okay. Everybody go to t-test. Okay. On your calculator. Do you notice here what we've been doing a lot is this stats button? Everybody now click on data. Whoop. Click on data right there. I don't know why I made that sound effect, but data. And now look, it's going to say, okay, what's your mu sub 0? What's the value in the null? So here you have to go back and you have to input this. It's 120. And look, check this out. It's saying, okay, all right, you have the raw data. What list is it in? It's in L1, so that's good. So I'm just going to leave that alone. Leave the frequency at 1. Okay, that means your data only comes up once. And then you're going to have to scroll down to mu and just make sure that here it matches your alternative, so which is not equal to. So you're going to click that right there.
Professor, I'm sorry to interrupt you, but I have sigma as 0.8 on my calculator. How do I get that?
Sigma as 0.8?
Yeah, I have 120, but before the L1, I have sigma and it says 0.8.
So what you got to do is you have to, did you hit stat? So hit stat on your calculator.
Okay.
Scroll over to tests.
Okay.
Did you go down to number?
Oh, I didn't do that. Thank you.
Yeah. And then you have to just click on data. And then once you have us all plugged in, you're just going to hit calculate right here. And then how many people see this right here on their screen with me? Melissa does. Does anybody else see it?
I don't. I have to try again.
You probably, if your values look close, or just a little different, it means you just inputted a number incorrectly. Okay, but most people do got it, so that's good. So if you have an error, just check your data, but follow along with me now because we're going to go through and make the conclusions and stuff. So look, the T here, this is your test statistic. It's negative, and it's okay to get a negative test statistic. Perfectly fine. Negative 0.6013. Why can't I ever remember? 6013. Then next, you see your p-value. It's right here. It's 0.5556 when I round it to 4 decimal places. 0.5556. Can you guys all hear my son in the background having the time of his life? You're okay, baby.
It's amazing.
Yeah. Yeah. Yes, it is good to be a kid. Yeah. Yeah. Oh, that's okay. Oh, that's okay. Yeah. Let me just go through this real quick. The conclusion step here now. Okay. Is my p-value greater than or less than alpha? So my p-value is, you notice how, yeah, it's greater than. P-value is greater than level of significance. Okay. So what does that mean we do here? Do we reject or fail to reject? Yeah, we failed to reject. What that means is evidence does not support the alternative. Okay, evidence does not support the alternative. So what's going on here is, look, even though the researcher thought it was different, there's no evidence to suggest that WCC students don't watch just the same amount of online lectures as every other college student at other types of schools. All right. Again, you know, your calculator, this is always given. This your calculator does. And really all you have to do is just look at the p-value, compare it to level of significance, and you know, there's a definitive way you do that. All right. So again, like I keep saying this, I think like the hardest part is just setting it up, right? Like once you set it up, it's not too bad. All right. You think you could handle one of these on the exam if I gave it to you? Maybe.
Yes, we can.
Okay. All right. Does it? So what'll happen on the exam when? And now again, I'm just going to deviate just a little, but it's covered in the review assignment. But when you do the exam, it'll say what is the conclusion. And there'll be 4 options. And the 4 options will be something like reject the null because the p-value is less than the level of significance, reject the null because the p-value is greater than the level of significance, fail to reject the null because the p-value is greater than the level of significance, or fail to reject the null because the p-value is less than the level of significance. So you'll just have to select the correct one. Yeah, you won't have to type it out. Like you'll just have to select it. Okay. All right, so what we're actually going to do today is we're going to skip the break. So hopefully if we have some time, if I can get through the next couple topics real quickly, hopefully if we have some time, then I'll be able to talk a little bit more about the exam at the end. Okay, so no break today, sorry. Everybody okay if I load up the next PowerPoint? Okay. So if you go into the classroom, if you didn't download it under course content, under week 14, this is our final PowerPoint of the class. We made it. Hypothesis testing for a proportion. So grab that one. So our last PowerPoint, we made it. I'm so excited for this semester to be over. I hope you guys are too. Okay. Yeah, seriously. I was going to say I was looking forward to sleeping in, but then I realized I have a newborn, so I won't be sleeping in for the next few years. Okay, so what I want to do is I want to just do one more example of the hypothesis testing for a mean, because I think I've done a right-tailed and a two-tailed test. So now, obviously I just want to make sure I get them all. So this may or may not be a left-tailed test. Okay. So the Fair Isaac Corporation, FICO, credit score, so this is your FICO credit score, is used by banks and other lenders to determine whether someone is a good credit risk, right? Like whenever you buy a car, they run your credit. This is one of the credit reports they got. All right, so scores on this FICO credit score range from the lowest credit score somebody can have is 300, and the highest somebody can have is 850. Okay. With a credit score of 720 or more indicating that a person is very good credit risk. So if your credit score is 720 or higher, you're good. Okay, people are going to lend you money. Okay. So an economist wants to determine whether the mean FICO score is lower than the cutoff of 720. Okay. So this economist, what they want to do is test to see, this is a little bad, but they want to test to see if on average people are not a good credit risk. Okay. So this keyword lower, okay, that's our first indication of the type of test. So when you see the word lower, what type of test does that kind of hint at? I think it's a left-tailed test, right? Yeah. So what this economist does is she finds a random sample of 100 people. So that's our sample size. And they had a mean credit score. So their sample mean, it was 703. And their sample standard deviation, S, was 92. Okay, so you got the mean and standard deviation. So can an economist conclude that the mean FICO score is less than 720? Okay, so what we're doing here is we want to test to see if the mean FICO score is less than 720. Okay. And again, we're going to use the 0.05 level of significance. Okay, so this one is a little bit trickier to set up, I think, than the other ones, okay? So what we got to do is we got to go through the 5 steps to solve this. All right, is everybody okay if I go to the next slide? Okay. So the first thing we have to do is we have to define the parameter. Okay. So what mean, going back to this slide here, what average are we investigating? Like, what are we trying to find the mean of?
Is it the FICO score?
Yeah, that's it. So we're going to let mu be the mean FICO score. Okay. And if you look back here, I said it was going to be a left-tailed test. Okay. And now I just need to figure out what numbers to put here. Okay. Does anybody have a guess? Remember, it's going to be the same number in both of them. Yeah, close. That's the sample mean. Yeah. So look, I want to show that it's less than, I want to look for evidence to show that it's less than 720. I don't know if it's less than 720 right now, but I want to find evidence to show that it is. So what I'm looking to show evidence for is that it's less than 720. So my null hypothesis will then be, well, okay, all right, if you want to show that it's less than 720, let's start with the assumption that it is 720. Okay, so we'll assume that everybody has good credit right now. That's our base assumption, okay? And let's look to show evidence that no, they don't have good credit on average. So I'll give you a hint, okay, for the exam. The null hypothesis is never going to be the sample mean value. Okay, it's always going to be something like in the first sentence or two. Okay, it'll always be like, oh, the mean is this, and then an economist wants to test this, blah, 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 and their sample mean was some other number. It's never the sample mean. It's always the first number. It's always the lead number. So level of significance, that's again is given as alpha. So now for steps 3 and 4, you're going to use your calculator. So everybody grab your trusty TI calculator here. Never lets you down. So I'm going to go back to the next slide, the previous slide, to get the information. Okay. So I'm going to hit stat. I'm going to scroll over to tests. And is it going to be option number 1 or 2 this week for this problem? Yeah, that would be option 2. So am I going to have, do I have data or do I have the summary statistics for this problem? Yep, I'm going to scroll over to stats. I'm going to hit enter. And you're just going to have to change this from the previous problem. So H sub 0 was from the null. So that's 720. X bar was over here. That was 703. The standard deviation S is 92 from the problem. And N is 100. Okay. So that's the sample size. So then what you have to do next is you have to change it to the less than sign. So I'm going to scroll down here. I'm going to go to the less than. And then scroll down to calculate. Right? How many people see this on their screen right here? Got it. Okay. Does anybody else get it if they're following along?
Yep.
Okay. Good, good, good. So look, the test statistic is negative 1.8478. The p-value is right here. It's 0.0338. So what do? We reject or fail to reject? What do we think? I don't know. Yeah, the p-value is less than alpha. Thank you. So we're going to reject the null. Because, oh my God, can't spell. The p-value is less than the level of significance. So what that means is evidence does support this. Okay, so what this is saying is on average, Americans are not a good credit risk. That's what this data is suggesting. Okay. So for this one, I've done a right-tailed, two-tailed, left-tailed. I've done one of every type. Okay. Are we now ready to do the final last topic and then we're done with the course? Except for the exam on Thursday. Ready. Boom. Yes, please. Okay. And here we are. Hypothesis testing for a population proportion P. Okay. And this is our final topic. So I know it's hard to always remember, but like the way we've done the topics of the class is like we've done confidence intervals for a mean, sigma known, confidence intervals for mean, sigma unknown, confidence intervals for a proportion. Then we did hypothesis testing for a mean, sigma known, hypothesis testing for a mean, sigma unknown, and now hypothesis testing for a proportion. And look, this is basically the same type of process in terms of hypothesis testing. It's still going to be a 5-step process. Just what you plug into your calculator is going to be different. Okay, that's what you're going to see as we go through this. All right, so it's the similar steps, just different notation. Okay, so no longer about a mean. Okay, it's just our parameter is the population proportion P. Okay, so it's going to be some number between 0 and 1. Okay, so again, you're going to have a two-tailed, left-tailed, right-tailed test. And notice this P sub 0 is just a number. Okay, notice that instead of mu, it's just equal to P. Okay, and I promise you, after I do the first example or two, this really like makes sense. Okay, I actually think that these problems are a little bit easier than the hypothesis testing for a mean. It's just like a little weird at first to get used to the notation. Okay, so these are the 5 steps. Okay, for this hypothesis testing for proportion using this p-value approach. So again, you're going to start by defining the parameter. Just in this case, it's going to be let P be equal to the proportion of whatever you're looking at. Then you're going to set up a test. Okay, so you're going to pick a test from previous slide. Okay, from right here. All right, and you know what? I have 3 problems picked out. We'll do a two-tailed, left-tailed, right-tailed in the time we have left. Level of significance. This is going to be given. So you're going to have alpha equal to a number. Next, instead of working through this formula, okay, we're going to find the test statistic and then the p-value. So TI calculator will do. And then your conclusion is still the same, okay? If p-value is less than alpha, you're going to reject the null. If p-value is greater than alpha, you're going to fail to reject the null. All right. So after we do the first couple of examples, it's going to be a piece of cake. And if you look in your calculator, just so you can see where this is going, if you click on the stat button and you scroll over to test, does everybody see option number 5 on their calculator? 1-prop z test. You see that? Melissa sees it. Does anyone else see that there?
Yeah.
All right, that's the one we're going to use for this, okay? So it was stat, scroll over to tests, and then it was option number 5, 1-prop z test. The one proportion, the 1-prop stands for one proportion. So we're only testing one proportion. And when you get here, I'm going to show you how to input all this stuff. Okay. It's really straightforward. It's like super, super easy. All right. Here's the, oh, sorry. Is everybody okay if I go to the next slide? All right. Here's the first problem. According to a 2010 Department of Education report, 30% of adults aged 25 years or older had a bachelor's degree or higher. Okay. So 11 years ago, all right, 11 years ago, it was 30% of people aged 25 years or older had a bachelor's degree or higher. So a researcher wants to conduct a test to see if the proportion of individuals who have a bachelor's degree or higher has increased since then. So that it's gone up since then. And this is in 2021 now, because that's what year we're in now. But you can obviously see what year this slide was made. Okay. So that it's increased. Okay. So when you see the word increase there, what type of test is this going to hint at? What do you think?
Tail.
Say it louder. You had it right.
One tail or right tail?
Right-tailed. Yep. All right, because I think this researcher thinks it's increased. So look, here are the things you're going to need. Okay. You're going to need the following things to plug into your calculator. To conduct the test, the researcher samples. So you need to know the sample size. It was 1,000 people. And this was aged 25 years or older, and finds that 320 have a bachelor's degree or higher. Okay. So that's your X. Okay. That's the number who meet that certain requirement. Okay. And look, you can see here, you can, if you guys remember, this P hat is just X over N. So it looks like in this sample, 0.32, okay? So it is a little bit higher, right? Like 11 years ago, it was 30%. We conducted this sample and got 0.32. Okay, so it's a little bit higher, okay? So at the 0.05 level of significance, so again, you're given alpha. Is there sufficient evidence to suggest the proportion has increased? Okay. All right, so just to rehash here, here's what's going on. I know what it was in 2010. Okay. It was 30%. I want to see if it's increased since then. Okay, so that it's gone up and that it's a higher value in 2021. Okay. So this is fun. This is fun. Let's do the problem. Is everybody okay if I go to the next slide? All right. Bum, bum, bum. So just got to go through these 5 steps. Okay. Going to define the parameter. I'm just gonna like jump through and do this problem so this first time so that you can see exactly how it's going, what's going on. So look, I'm gonna let P be equal to the proportion of 25 adults 25 years or older who have a bachelor's degree or higher in 2021, because we knew what the proportion was in 2010. I'm looking to see what it is now in 2021. All right. Now I have to set up the test. And look, we said it's increased, so we think it's a right-tailed test. So to set this up, it's going to be right-tailed. So it's going to be P is equal to some number, and we're saying no way P is greater than a number. Okay. So do you guys remember I said like I generally said the value that goes in the null hypothesis is like the lead number. Do you guys remember me saying that in the previous example? Like generally for the problems I'm going to give you, I'm going to lead with that number. Yeah. Okay. So look, we knew what it was in 2010. It was 30%. And what we want to show now is that this P, it's no way. It's 11 years later. College is really important. So no way. It's greater than that 30%. So we're going to change it to a proportion. It's greater than 0.30. Okay. All right, level of significance given 0.05. Grab your trusty calculator. So you're going to hit the stat button. You're going to scroll over to tests. And what option was it again that I said it was?
Number 5.
Number 5. 1-prop z test. Go to number 5. Okay. So P sub 0. All right. That's whatever you had in your null. So it's 0.30. Check this out. Your X going back. That's the 320 people who said, yeah, I have a bachelor's degree or higher. And how many people did they sample? That's 1,000. And then you just have to go and make sure that you change the alternative to be greater than. See how it's greater than here, greater than over here. And then you're going to scroll down to calculate. Okay. How many people see these results right here? Boom. Okay. The test statistic is right here. It's this Z, 1.3801. That's the first thing. Test statistic, 1.3801. P-values next. Boom. P-value is 0.0838 when I round it to 4 decimal places. 0.0838. Okay. So what's the conclusion? Is the p-value, so be careful. Is the p-value less than or greater than alpha? Is 0.08 greater than or less than 0.05? Got it. Yeah, you got it. Yep. So the p-value is greater than the level of significance. Right? 0.0838 is greater than 0.05. So what do? Do we reject or fail to reject? Bum, bum, bum. You guys have, it's been a while, but that's it. Thank you. We failed to reject. So I had this silly saying, right? Like when the p-value is low, the null must go. When the p-value is high, the null must fly. So what this means when the p-value is high is we can't reject this. Okay, so what this is saying is evidence does not support the alternative. So for whatever reason, it doesn't look like there's enough evidence to suggest that, more people are going to college than 11 years ago, for whatever reason, Yeah. Like if I could do it all over again, I might be an electrician or a plumber, because every time those guys come out, I feel like I have to give them $1,000. I don't know why. No matter how long they're here, 15 minutes or 3 hours, it's like 1,000. It's true. It's true. Wait till you guys all buy your first home, or if you're homeowners, it's true. It's brutal. All right. Ready to see the next two examples? And then hopefully this will make more sense. But again, you guys notice the hard part is just setting it up, and then boom, boom, it's calculator. I hope so. All right. All right, so this is a tricky one. Okay, let me see example 2. All right, yeah, example 2. This is a tricky one, okay? In a national poll, okay, 1,053 US adults were asked, do you support passage of an economic stimulus bill that included support for state budgets? Okay. So like this was actually a big thing in the news a while ago, like the during the coronavirus lockdown, this was a very common question because how blue states and red states handled the lockdown were different. I'm not just saying which one was better or worse. It's just like the blue states had higher state budgets, and when they locked down, they lost revenue, and they needed a bailout from the federal government. Okay. And some people were for that, some people were against it. Okay. So I'm not going to get into any politics of it. So what you're seeing right off the bat here is this is your sample size. Okay. Of those sampled, okay, 548 favored passage. Okay, so that's my X. These are the people who favored passage. Okay. So at the 5% level of significance, so that's alpha is equal to 0.05. This is where it gets tricky. Does the data provide sufficient evidence to conclude that a majority of US adults support passage? Okay. This is what we're looking to test. We want to find sufficient evidence to conclude that the majority of US adults support passage. Can anybody guess what the key word here is that's going to give away what type of test this is?
Majority?
Oh, that's it. This is the key word right here. That's giving away the type of test. All right. So now the next question is, in terms of a proportion or a percentage, what represents a majority? If you're going to be a majority, you just have.
Population.
Sorry, I couldn't hear you. My little guy's having a problem.
Sorry, can I say PS population?
Well, hold on. So to be a majority, you have to be greater than what percent? So let's start with that.
At least 50?
Yeah. So here's the thing: if you want to be a majority, okay, of something, you need to be greater than 50%. So a majority is greater than 50%. Okay. So look, greater than. So what type of test does this imply it's going to be now? So here's the thing, Melissa. 51% would be a majority, but would 50.5% be a majority? Would 50.1% be a majority? Yeah, see what I mean? 50.000001 would still be a majority. So you just have to be over 50%. That's it. Boom, just over 50. So the greater than implies that it's going to be a right-tailed test. Okay. So here's what we know. Okay. I've got my sample size. I've got the proportion that do favor support of this passage. So you can see if you were to even just take 548 and divide it by 1053, you would see that it's 52. So it's 0.52. So here's why I also like this problem. Like, you guys ever see polls where it says something like, oh, 52% of Americans support this, so it must mean there's a majority? You have to be like, I mean, is that really what it's saying? You know, that's just like 52% from one sample, you know? So like, let's go through this hypothesis test and see if we can indeed say that a majority, based on this poll, a majority does support passage. Okay. All right. Is everybody ready to see us walk through this together? All right. So 5-step, we need to define the parameter. So what is P? I'm going to go back a slide. What are we, like, what's the proportion? We're interested in the proportion of people who what? Support passage. Yeah. Support passage of this bill. So we're going to let P be equal to the proportion of adults who support passage of the bill, of this stimulus bill, and now here's where it gets tricky. We want to test to see if it's a majority, so we know it's going to be a right-tailed test. My son is groaning at this problem. Not a funny joke. Maybe. I don't know. So what do you guys think? What number are we going to put there? Well, look, we want to test to see that it's greater than 50%, right? Like, that's what we want to find evidence for. So I want to show evidence that this P is greater than 50%. okay? So then we need some assumption then to start with. So let's assume that it is not a majority. Let's just to start with the assumption that it's only 50%, okay? And we want to show evidence for this, okay? So does evidence support this? All right, so level of significance, boom, it's 0.05. So here, test statistic and p-value, you're going to jump right to the calculator. All right. So I'm going to press my stat. I'm going to scroll over to tests. And again, it's option number 5 here, 1-prop z test. Option number 5, 1-prop z test. So look, p sub 0, you're going to put in this 0.05, 0.50, I'm sorry. X, you're going to go back here. It was 548. And my N was 1053. And then you're going to scroll over and have it be a greater than here, okay? And then you're going to scroll down to calculate. And then how many people see this on their screen right here on their graphing calculator? Awesome. So it looks like my Z is 1.3251, my test statistic. And my p-value is right here. It's 0.0926 when I round. So 0.0926. Okay. So what does that mean? So are we rejecting or failing to reject the null? Is our, yeah, p-value is greater than. So we reject the null, or we fail to reject the null. All right, this is because p-value is greater than level of significance. I really like doing this problem because it's super interesting, because this survey came out and said that 52% supported passage, which is greater than 50%, right? It's greater than 50%. But even though you just took this sample of 1,053 people, and even though it was greater than 50%, it just doesn't provide enough evidence to say for sure that all the adults in the United States, the proportion of all the adults in the United States who support this bill is greater than 50%. So when you see things in the news like that, like a poll comes out and 52% of Americans support this, it doesn't necessarily mean that there is a majority. Okay, it doesn't really provide strong enough evidence. All right. What do you think? Not too bad? Again, is this just the tricky part? Step 1? Yeah. If you can set this up, then the rest just boom, boom, boom falls into place. Yeah, these ones are a little different for sure. These are the proportion ones can be a little bit trickier, a little bit harder. All right. So how about let me do one more example, and then I'll actually have enough time to talk about your exam for you, okay? Does that sound okay? Okay. So here's the problem. Okay, 3 sentences. Okay, so this researcher comes out and he or she says, you know, look, 10% of the US population is left-handed. Okay. So this researcher is just flat out saying 10% are left-handed. That's it. Okay. That's the deal. So, like, is this like maybe this is true or false? I don't know. Okay. Okay, we need to test this. So in a random sample of 750 adults, so you're given the sample, individuals, excuse me, sample size. It was found that 92 were left-handed. So based on this sample, if you were to take 92 and divide it by 750, you'd get this. So 0.122, 7 basically. So this is tricky, okay? Does the data support the claim by the researcher and use the alpha is equal to 0.05 level of significance? Okay. So this researcher, he or she is saying, look, 10% of the population is left-handed, okay? And so we want to know if the researcher is right or not. So this is the hard part. You have to figure out now how to set up this test, okay? And then once you set up this test, boom, 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 it's going to be a piece of cake in your calculator. All right, is everybody okay if I go to the next slide with this? Okay. So define the parameter. So we want to test the claim by the researcher. So we're interested in the proportion of people in the population who are what? Like, what are we investigating? The proportion of people who are what in the United States? Left-handed, yeah. Yeah, like my wife is left-handed. My sister's left-handed. I think my son is left-handed. Okay, we're interested in the proportion of people who are left-handed. Yeah, left-handed, lefties are cool. I'm right-handed, but I think being lefty would be cool. Okay, so this is the hard part. Again, you have to figure out how to set up this test. All right. So all I want to do is see if the researcher's claim is true or false. Okay. So what the researcher's claiming it's 10%. Should anybody have a suggestion on what the alternative might be? I just want to know if the person's right or wrong. That's it. Well, let me ask you this. They're claiming that the proportion is 10%. That's it. Could the real percentage of people in the left hand of the United States be less than 10%? Could it also be that the real proportion is greater than 10%? Like, I have no idea, right? Like, I don't know what it is. So the way I'm going to set this up is if they claim it's 10%, just check if their claim is true. Okay. All right. Let's start with the assumption. Yep. That's it. You got it, Melissa. Yeah. Start with the assumption that it is 10%. And look, I'm going to test to see if it's not 10%, to see if you're wrong. Okay. And then once you have that set up, it's boom, boom, boom. It's going to fall right into place. Okay. Level of significance, again, is 0.05. So let's grab our trusty calculator. So you're going to click stat. You're going to go over to tests. And it's 1-prop z test. So my null was 0.10. My X was 92 people. My N was 750. And I just have to switch it to not equals, okay? Because I have to match this. And then you're going to scroll down to calculate. And then how many people see this right here? Okay. Look, Z is equal to 2.0692 when I round it. And then my p-value right below it is 0.0385. I don't know. So what do you think? Is the researcher right or wrong? Are we rejecting or failing to reject the null? Yeah, look, the p-value is less than alpha. So what's going on here is evidence supports the alternative. And what we're saying here is the researcher's wrong. The researcher's claim is wrong. And actually, I do think I did look it up. I think it's like 13% of the population is left-handed. So the researcher's just way wrong. They're way off. And that's it. Again, you just have to be very careful how you set it up. Just like read the problem super carefully. Look for the keywords where you can. And then you're all set. All right. What do you say I talk about the exam now with the time we have left?
Please.
I'm sorry?
I said please.
Okay, gotcha. All right, for those who came late, and just as a reminder, okay, because I had to cancel a day, I'm going to change the syllabus a little bit. So the syllabus says I drop your lowest exam from exams 1 to 3. So I'm going to drop your lowest exams from exams 1 through 4. So, you know, including your last exam. But the deal is you just have to take the exam. You have to take it, okay? You have to give it your best shot, okay? So if you scroll under course content, under week 15, I hate to admit this, but I'm giving the same exact lectures I gave last semester, okay? The same PowerPoints, everything. So this is the recording I gave, the review class I gave from last semester, okay? So I think it's an hour and 10 minutes. So if you were to watch this, you would put in on the exam, the level of significance. I talk about your homework in here. I do a bunch of examples from the exam. And here are the PowerPoints I used. I used the PowerPoints without the notes and the PowerPoints with my notes. And if you open up the PowerPoint, this is the format of the exam topic. So there are 12 questions on the exam. Okay, it's only 12 questions, really short. So your first 6 questions are confidence intervals. So these are all questions from your using your graphing calculator. So if you look on the slides here, your first question is going to be a confidence interval for a mean sigma known. The first example I do in this PowerPoint slide is that example. Question 1 is literally going to be, what is the lower bound for the confidence interval? Question 2 will be, what is the upper bound for the interval? And then it's going to go into a mean for sigma unknown. That's the second example I do. And look, I even tell you in the notes here, like what options to press in your calculator. Okay. Lower bound then upper bound. Then for a proportion, options in the calculator. Where is it? Do I have it in here? I might not have that example in here. I take that back. I might not. But this one here, you're just going to use the 1 dash prop z interval here. And then there's going to be 2 hypothesis testing questions. You'll notice that the hypothesis testing questions have 3 parts to it. The first question is literally going to be like a multiple choice question that says, what is the null and alternative hypothesis? The second part of the question will say, what is the p-value? And then the third part of the question will say, what is your conclusion? Okay. So if you just really carefully read the problem, it's really not that bad, the exam. Okay. So watch this lecture here. Literally just, it takes a couple minutes. And if you look, I think I even load up the exam at some point and show you what the questions might look like. Yeah, you can even see here. Like I load, you can see what the exam looks like here. Okay. So you can see I loaded it up and you can see like select the right, hypothesis test and so on. Okay. Does anybody have like any specific questions they have for me at this point about any of this? No questions? All right. The other thing is then have your homework in Thursday night. I am literally going to do your grades on Friday. So what is going to happen is on Friday, I will calculate your grade and then I'll put it in the grade book. And I'll shoot you an email just to let people look over the grade, just to confirm that I did it right. And give you a chance to like correct any mistakes I have in the grade book. But then other than that, then I'm going to submit final grades on Monday, next Monday.
I wish you would teach pre-calculus. I would love to have you again.
Let me stop the share for a second. Let me stop the recording.